Good morning. Thanks for joining. Let's start our session. So, and this is day two session on our particular course we are discussing. So yesterday we started the introduction part of DevOps. We have seen what is DevOps and how DevOps came into the picture. All those things we have seen yesterday. And let's go through them once again, and we'll move to the further topics. Okay. First of all, we should be very much confident on the basic part, like we need to understand the actual meaning of DevOps and how actually the DevOps came into the picture. Okay. Anyhow, we already discussed this in the day one. So let's continue. Let's discuss this for few minutes, and we will move on to the further things. So we have seen already like what is DevOps. DevOps is nothing but it is a combination of development team and operations team. Okay, two teams you see here. It is a combination of development team and operations team. And I told you like what is the meaning of what is development team? Development team is nothing but people who will be working on coding, part. So if he is a Java developer, he will be working on Java. If he's a .NET developer, he will be working on .NET, Python developer. So who will be working on coding part, they will be called as developers. And what about operations team? As I told you, system admins, system administrators, database administrators, people who maintain and manage the infrastructure. People who manage and maintain the infrastructure, they will be called as operations team. So why we were discussing about these two teams? Because DevOps is a combination of development team and operations team. It came into the picture, DevOps came into the picture because there is a gap between the development team and operations team. So why the DevOps came into the picture? DevOps came into picture because there is a gap between development team and operations team. To bridge the gap, the DevOps team was introduced. And what is the gap? We need to understand. What is the gap between development team and operations team? We need to understand. So let's see an example to understand. Okay, we'll discuss about a few examples to understand what is the gap between traditional, what is the gap between this developer and database, the gap between the development team and operations team. Let's understand that one. We need to understand the gap between the development team and operations team. So try to understand, consider we are taking an example that developer needs a database. Developer needs an SQL database to work on some feature. So developer is sending an email to the database team. Okay, developer is sending an email to the database team. So requesting to set up the database. Usually it happens, right? Whenever a developer, whenever some team needs something, whenever a particular needs something, developer, that particular team will approach the related team in the project, right? So that in that way, developer is required some kind of database. He is approaching to the database team, requesting to set up it. So what is the response that he got from the database team? Database team is replying saying that DBA is not available. Maybe because of workload or because of other priority issues. Maybe he's working on other priority issues or because of high workload. So he's not available. DBA is, they shooted a mail saying that DBA is not available. And so in that case, what happens? Developer will stuck waiting. Developer will not move forward with this work. Developer will get stuck, and which cause the delays in the project. Try to understand this example. Developer is requesting to set up a database to the database team. And what is the response that he is getting? No DBA available because of some issues. So that's the reason why developer got stuck. And usually when the people got stuck, usually the impact will be like it will cause delays in the project. Right? So this is the traditional approach. If there is no DevOps methodology, this is how actually happens. This is what happens if there is no DevOps methodology. Suppose if there is a DevOps methodology, how actually the things will be. Try to understand. Suppose if there is a DevOps methodology, if the developer knows DevOps tools. Usually today, the industry is expecting all the developers should be aware of the DevOps tools. Okay. So let's see the approach. Okay, let's see the approach. What is the DevOps approach? Suppose in the same example, okay, the same example we are going to consider. The same example we are going to consider. Suppose if the developer needs a database, developer shoots an email asking to set up the database. Okay. Usually, see in this example, okay, in the previous example, what we have discussed is developer needs some database. In that case, he is requesting for database team. But in the DevOps approach, if the developer already knows some DevOps tools, the developer is already aware of the DevOps tools. Definitely, developer uses a tool called Docker. Developer uses a tool called Docker, and he will try to install the database. Either it is locally or in the cloud. So with a simple command, developer can have a fully functional database running either locally or in the cloud. Hope you understood, right? If this is the case where developer is aware of some DevOps tools. If developer is aware of DevOps tools, developer needs not to be dependent on any particular team. Here in the first example, developer is waiting for the database team to do that. But here developer is aware of DevOps tools. If he is aware of DevOps tools, with the help of a very simple command, developer can set up a database and he will proceed with his work. So that is the difference. Okay. No need to depend on some resource. No need to depend on particular team. Okay. This is how we need to consider as an example. That is how the gap between the development team and operations team. So hope you got it. So this is an example. Maybe we cannot understand now the meaning of this Docker run command and all. Maybe we cannot understand. So whenever we discuss about this Docker concept, maybe you understand. I'll explain you very clearly how we are going to run the Docker commands. What is the use of Docker? But for now, you need to understand that Docker is a containerization tool. Docker is a containerization tool. Okay. Now, if you don't know the meaning of containerization tool, we will be discussing in the further sessions. So next, and you see here, as earlier we discussed about like how the DevOps came into the picture, and we also need to understand what were the models that we were using earlier. Today, if you see in any of the organization, okay, today in most of the organizations we use agile model with DevOps tools. In most of the organizations today, we use agile model with DevOps tools. Okay, maybe we need to understand what is agile model and what is the difference. Earlier, we were using some waterfall model also. Okay, before today, we are using agile model with DevOps tools implementation. Most of the organizations use agile model with DevOps tools implementation to deliver the software faster. But earlier, we were using waterfall model. There are some drawbacks in the waterfall model. That's why we started using agile model. There were some drawbacks in the waterfall model. What are the drawbacks in the waterfall model? You see here, projects will take long time to complete. If we start with waterfall model, if we start any project with waterfall model, usually projects will definitely take long time. Can anyone say why usually the projects will take long time if it is a waterfall model? You can look at this example. I'm showing you one example. Here you can see the different stages. What are the stages? What are the different stages that we will be having in any of the models? Usually in any software development lifecycle. See, we are discussing about the waterfall model, agile model, all these things, right? Agile model with DevOps methodology, DevOps tools implementation. We are discussing about many models. So in any model you take, it will be called as a software development lifecycle. What is waterfall model? It is one of the SDLC. It is one of the models in SDLC. What is SDLC? Anyone, please? What is SDLC? Software development lifecycle. To start any project, we simply follow one software development lifecycle. Under SDLC, we have many models: waterfall model, agile model, and today we are using agile model with the DevOps tools implementation. Why we move to agile model with DevOps tools implementation? There are some drawbacks in the waterfall model. Earlier we were using waterfall model. Later we switch it to agile model. And today we are using agile model with DevOps tools. Very simple example I can say you. Suppose if we use waterfall model, the project is taking a total time of 16 months. Consider a small project which is taking a time of 16 months. If we use waterfall model. If we implement any project with waterfall model, the project is taking a 16 months time duration. And after switching to the agile model, usually the projects we used to complete the project in 6 months, the same project. You take the same project as an example. If it takes 16 months with the implementation of waterfall model, with the agile model, we could able to complete it within 6 months. And you see, later we moved to agile model with the DevOps tools implementation. We started using DevOps practices. And could you guess what is the time duration? We were able to complete within 3 months. Where is 16 months? By using waterfall model, it was taking 16 months. Later we moved to agile model. In the agile model, we could able to complete it in 6 months. And later when we started using DevOps practices, we were able to do it in 3 months only. Why it is happening like this? Where is the gap? You can understand now. We need to understand where is the gap. You see here, in every model, we will be having the same stages only. Requirements gathering, analysis, design, coding, testing. Okay, in any model, not only waterfall model, you take agile model or you take any other SDLC models, definitely the stages will remain same. What is requirements gathering? You know, right? Gathering all the requirements for the project. As I told you one example yesterday, ICICI Bank or HDFC Bank, they need one internet banking application. They approached any software company like Infosys or Wipro. So what is the first step they will do? What is the first step? How it starts is like they are going to collect the requirements. Company will ask for the requirements. IT team will ask for the requirements. That's how it will get started. Once the requirements are collected, what is the analysis stage? Analyzing the requirements. They will go for analyzing the requirements. So they'll go for the detailed specification. What actually the ICICI Bank asked and how they are going to do it. They will analyze all the requirements. And you see here, for collecting the requirements itself, it took 6 months. In the waterfall model, for example, for collecting the requirements itself, it took 6 months. And you know what is the biggest drawback in the waterfall model? Each phase of the software development life cycle is completed sequentially. Meaning, if requirements phase is not completed, they will not go for analysis. If analysis is not completed, they will not start design phase. If design phase is not completed, they will not go for coding. If coding is not completed, they will not go for testing. So all the stages will be done sequentially. In waterfall model, all the stages will be done in sequential manner. Meaning, once the requirements phase is completed, then only they will go for analysis. Once the analysis phase is completed, then only they will go for design phase. And you see here, when the requirements phase is in progress, when the requirements collection is in progress, all the other teams, you see, analysis team, design team, coding team, testing team, all the other teams will be sitting ideally without having any work. They will not be having any work, right? Why? Because requirements team will take 6 months to gather all the requirements. And according to waterfall model, they will not start all the remaining phases without finishing this requirements collection. Okay, if there is a dependency on each and every stage. That's the reason why it is taking much time. That's what I'm saying here. You see, the next phase cannot start. The next phase cannot start until the previous one is finished. This is a drawback in the waterfall model. That's why it used to take much time. That's the reason why waterfall model used to take much time for completing the projects. And hope you know the meaning of each and every phase here. Analyzing, what is design? Design is nothing but they'll decide the technologies. They used to decide the technologies, like what type of technology we use, either Java, .NET, What kind of technology we use Python? They'll go for designing the architecture and components. There are components in the sense like programming languages, front end, back end, all the things. Anyhow, we are aware of the coding part. Once the technology is decided, once the technology is decided, then they'll go for the coding part. Once the coding is done, they'll go for the testing part. This is how a very sequential manner. All the steps will be executed in a very sequential manner. That's why this waterfall model used to take much time for executing the projects. And let's come to since there were some drawbacks in the waterfall model, we are going for the agile model. Okay, since there were some drawbacks in the waterfall model, we started using agile model. When we started some 10 years back itself, we started using agile model. You see, what is the difference between waterfall and agile model? Whatever the phases we have in waterfall model, the same phases we have in agile model also. You see, requirements, analysis, design, coding, testing, everything will be there. All the phases will be there. But the only difference is here all the phases, all the activities happen in parallel. All the activities will happen in parallel. You see here, for the requirements collection, they are not going to collect requirements for all the modules. In agile model, according to agile model, requirements will not be collected for all the modules. Yesterday, I was telling you, like, what do you mean by modules and all? If I open any of the net banking website, if I take the example of ICICI Bank net banking website, you see here, I have accounts, deposits, payments, cards. We have many modules, right? So this will be called as accounts module. And this will be called as deposits module. This will be called as payments module. So what they will do, according to the waterfall model, they will collect requirements for all the modules, for the accounts, for the deposits, for the payments, cards, loans. For all the modules, they will collect the requirements at a time. Then only they will move to the next phase. But that will not happen. Okay. So we are trying to overcome the drawback which is present in the waterfall model. In the agile model, okay? In the agile model, we are trying to overcome the drawback present in the waterfall model. What is the drawback? You see, here in agile model, they'll collect the requirements only for one module first. They'll collect the requirements for only one module. Consider for collecting the requirements for one module, if it is taking only for 1 month, and they will give the requirements to the next phase, the next team. Okay, once they collected the requirements for one module, they will give the requirements, they'll hand over the requirements to the next team, analysis team. And once analysis team analyzed what kind of specifications, what kind of, how they are going to implement it, and they will give their analysis to the design team. And the design team, once they are done with the design part, they'll give the design to the coding team. You see here, all the teams will simultaneously work here. First, the requirements team collected the requirements for account module, as I shown you. They collected the requirements for account module and handed over the accounts module requirements to the analysis team. And the requirements team will not sit ideally now. Requirements team is having work now. Requirements team will go for collecting the requirements for another module called deposits. Requirements team will go for collecting the requirements for another module called deposits. Hope you understood, right? Meanwhile, the remaining teams will be working. Okay, when the first team is working on, sorry. So what is happening here? Well, initially, what happens? First, they'll collect the requirements for the first module, and the first module will be handed over to the analysis. For the first module, once the analysis is done, they'll give the analysis to the design team. And during that time, this analysis team will not be sitting ideally. Analysis team will get the work from the requirements team for the second module. So analysis team will start analyzing the requirements for the second module. They will give it to the design team. Like that, all the teams will work simultaneously. All the activities happen in parallel. You know, in the agile model today, we used to call it as sprint. Sprint in the sense, we'll plan the work for 15 days or for 13 days. We will target some work. So within these 30 days, we are going to complete all these tasks and all. We are planning like that, and we will be moving ahead. Got it, right? Which is what is called sprint. Sprint is nothing but we are going to divide. What is agile model? In the agile model, we are going to work in the form of sprints. What is sprint? We are going to divide the project into smaller iterative cycles, smaller cycles called sprints. So for 15 days, for the first 15 days, we will target some tasks. We will complete it and we'll go for the next 15 days. We are going to plan what we are going to do in the next 15 days or next 30 days, which is called as a sprint. So the duration for sprint will varies from one project to another project. In some projects, the sprint will be for 15 days. In some projects, might be the sprint will be 1 week. In some projects, the sprint might be for 3 weeks, 4 weeks. Usually, it lasts from 2 to 4 weeks. What is the sprint duration? Normally, it will be like 2 to 4 weeks. Most of the projects, they use 2 to 4 week sprints. So still there is a drawback. Okay, now we have discussed like there were some drawbacks in the waterfall model. We try to overcome the drawbacks. So that's the reason why we started using agile model. Yes, even though we started using agile model, we were able to do it in 6 months only. We were able to do it within 6 months only. You see, in waterfall model, we were able to do it in 16 months, and once we started using agile model, we could able to do it in 6 months. Later, so most of the software companies have done a research. Most of the software companies have done a research, and they still try to identify the gaps. Why still it is taking 6 months of duration? Why can't we do it in a very short span of time, less than 6 months? Okay, most of the software companies have done a research on that, and they came to know that we might use, okay, it's better to use the DevOps practices. Okay, in their research, they came to know that there is a gap between the development team and the operations team. So where the things are getting delayed, because development team is depending on some other resources like system admins or other kind of resources. As I told you, right? One example, developer is requesting for a database to the database team. So the database team saying that DB is not available. So these kind of scenarios, they leading to the delays in the project. These kind of scenarios were leading delay in the project. That's the reason why. So software companies have done a research and they identified that some DevOps practices needs to be implemented. If we implement agile methodology with DevOps practices, we can able to do it within a very less span. So what do you mean by DevOps practices? So the people who are working, okay, the developers, the other resources who are working in the project, they should inculcate the DevOps practices. Or otherwise, there should be a DevOps resources. People who knows to use the DevOps tools. Who are DevOps resources? Usually, what is DevOps team? People who are aware of DevOps tools, who knows how to install DevOps tools and how to use the DevOps tool. They are called as DevOps people, right? So the developers might also understand how to use these DevOps tools and all, so that they will not depend on the other resources. The main objective is there is a gap between the development team and operations team. That's the reason why we should implement the DevOps practices so that we can able to do it in very short span of time. Okay. So here also we use the same methodology, agile methodology only, but additionally we are using DevOps tools. So it's just because you see here, since we are using the DevOps tools, we could able to do it within the 3 months. Earlier we were using only agile model. How much time, how much duration was it taking? It was taking 6 months. Now we were using agile model with DevOps tools implementation. Now we could able to complete any project within 3 months. I'm just taking an example and explaining you. So what is the reason? Because here we are implementing automation. You see here, what is the additional thing that is happening here? Because of this DevOps tools, since we are using the DevOps tools, what is happening? We are implementing the CI/CD part. What is the CI/CD? Automation. We are implementing some automation for automating the builds, for automating the testing, for automating the deployments, to speed up the process. We are automating everything by using DevOps tools. Earlier, people used to do it manually. So once the DevOps tools came into the picture, we are automating everything. We are automating the builds, testing, deployments, everything to speed up the process. That's the reason why we could able to do it. Okay. Short time than the agile model. We could able to do it in a short time than the agile model. Any questions here? This is what the introduction part we have seen yesterday. This is what you need to understand what is DevOps related to the DevOps and all. Any questions we have, we can discuss. I'll give some time. If you have any questions, we'll discuss. Then otherwise, we'll move ahead and we will see the agenda for today. Any questions? See, it should be like an interactive session. Otherwise, it will be very difficult for me also to explain all these things. Okay, if you have any questions, feel free to ask, please. Okay, then. So, moving forward, let's see the agenda for today. Okay. So, we need to understand, okay, fine. We understood the basic idea of DevOps. Okay. We understood the introduction part of DevOps. Then what else we need to understand? Let's see. Okay. We have many DevOps tools. So, we have many tools like Git, Maven, Jenkins. Let me show you. Let me, yes. Okay. So, let me show you what are all the DevOps tools that we are having. Maybe you are aware of the DevOps tools and all. So if we talk about the DevOps tools, usually these are the things that will come into the picture. Like Git is one of the tool, okay? Git, otherwise GitHub, okay? Git or GitHub. So Maven is one tool. The Jenkins is another tool. Docker is another. These are the very, very important tools that we are discussing, okay? Jenkins, Docker, Kubernetes, okay? Kubernetes will be shortly, in a short form, it is called as K8s. Kubernetes in a short form will be called as K8s. And we have other tools like Terraform, Ansible. Okay. So Git, Maven, Jenkins, Docker, Kubernetes, Terraform, Ansible, all these are the tools. Okay. All these are the very, very important tools that we have. So we need to understand the actual flow where a particular tool is required, where we need to use a particular tool. Okay. Let's understand. So for your understanding, like what I would like to say is, you need to understand what is this Git first of all. What is this GitHub? Anyone heard about GitHub? Anyone heard about GitHub? What is a tool called GitHub? You know, in a short form, it is called as an SCM tool. You know what is the full form of SCM? SCM stands for source code management. SCM stands for source code management. Okay, SCM tool. SCM stands for source code management. And what is this Maven? Maven is a Java-based build tool. Maven is a Java-based build tool. So if someone asks you what is Maven, we should be able to answer. Maven is a Java-based build tool. And you know what is Jenkins? Jenkins is a CI/CD tool. The full form of CI/CD is continuous integration and continuous delivery. Full form of CI/CD, few people will call it as continuous integration, continuous deployment. Actually, the meaning is continuous integration and continuous delivery. The full form of CI/CD is continuous integration and continuous delivery. Okay. And the next one is Docker. So what is Docker? Docker is a containerization tool. Docker is a containerization tool. So I'm not going with the meanings now. What is containerization tool? What is CI/CD tool now? So just now we people need to understand what actually the tool is called as. GitHub is an SCM tool. Maven is a Java-based build tool. Jenkins is a CI/CD tool. Docker is a containerization tool. What is K8s? It is container orchestration tool. Okay. It is a container orchestration tool. We'll see the meaning of container orchestration. What is container orchestration? All those things. Okay. No worries. So Terraform is simply called as IAC tool. Do you know what is an IAC? IAC stands for infrastructure as a code. And you can also see what is Ansible. Ansible is a configuration management time. Okay, please take some time to see what is this tool and what actually the tool is called as. GitHub is called an SCM tool, source code management. Maven is a Java-based builder tool. Jenkins is a CI/CD tool. CI/CD stands for continuous integration, continuous delivery. Docker is a containerization tool. We'll go through the meaning of containerization later. And what is Kubernetes? Kubernetes is container orchestration tool. Kubernetes is a container orchestration tool. What is Terraform? Terraform is an IAC tool. IAC stands for, what is the full form of IAC? Infrastructure as a code. IAC stands for infrastructure as a code. Ansible stands for configuration management. Ansible is a configuration management tool. Okay, these are the tools that we will be discussing mainly as a part of DevOps course. So let me go through. So let me explain you the actual flow that happens. Let me explain you the actual flow that happens here. How the actual flow that happens. So for that purpose, I have explained, I have opened this screen to explain you. See here. So what happens is, like, first of all, let's see. We have a tool called GitHub. We have a tool called GitHub. Anyone knows what is GitHub? Just now we explained, right? What is GitHub and all? What is GitHub? What is
Source
GitHub?
code management.
Yes, GitHub is a SCM tool, right? GitHub is an SCM tool. Source code management tool. See, by the name itself, we can easily identify that it is a, by the name itself, we can identify that it is a tool which is used for source code management. It is a tool for source code management. Let's understand what actually the things will do. So source code management, how actually the tool is used. Consider we have few developers in a project. Okay. Consider we have some few developers, like 3 to 4 developers are there in the project. And they're working on their tasks. Okay. They'll be working on their individual tasks. So developer one and developer 2. See here, developer 2, developer 3, developer 4. So there will be many developers, but I'm just taking an example of 4 developers who will be working on their independent tasks. Developer 1 is working on some task. Developer 2 is working on some other task. Developer 3 is working on his own on his task. Developer 4 is also working on the task. So if the people are working on their individual tasks, on their tasks, so once the task is finished, once they are done with writing a coding, once they are done with writing coding part, which is assigned to them, where they are going to keep the source code? Usually they are going to keep the source code. There should be one place, right? We should have one place where they are going to keep the source code. We are going to manage the source code. So GitHub is the place. So once the developer 1 is written, once the developer 1 is done with his coding part, he will commit the code into the repository called GitHub. Similarly, developer 2 will also commit the code into GitHub. Developer 3, developer 4, all the developers will commit the code into the repository called GitHub only. And why all the developers are committing the source code? Why? Because this is an organization repository. So we are managing our code here. We'll be managing our source code in a tool called GitHub. So GitHub is the only tool that usually organizations use? No, there are many tools. There is a tool called Bitbucket. There is a similar tool like GitHub. There are many similar tools like GitHub. Earlier we used to have SVN, subversion systems. That is also a source code management tool. SVN is also a source code management tool. There is a difference between SCN, GitHub, all those things. But whenever we discuss, see, we will go into the details much when we started discussing about GitHub. Okay. So for now, what I would like to explain you is GitHub is a source code management tool. All the developers, they will try to push the source code into a common repository, which is called GitHub. So usually they will work, they'll try to write the code locally in their local machines. Once they are done with the coding part for the assigned task, they'll commit the code into the GitHub. Every developer, they will not keep the code in their local machines, right? Usually, we should not keep any code in our local machines, whatever the code that is written by us. We should be committing everything into a tool called GitHub, right? Consider all the developers has committed the code into a tool called GitHub. So now the GitHub is having a code as a DevOps resource. Okay, as a DevOps resource. What is your, so DevOps resource will take care of, DevOps engineer will take care of two things. Okay, we should be very clear in two things. We should be aware of, setting up the infrastructure. Meaning, if there is no GitHub for your organization, you should know how to set up a GitHub and how to create all the things, how to create organizations, how to create repositories, how to create all the things inside the GitHub. You should know. Okay, how to set up GitHub and all. Two things. Infra-wise, we should know. Okay, infra-wise, we should know. And we should also know the CI/CD part. We should know the CI/CD part. Continuous integration and continuous delivery. We will, I will make you understand what is CI/CD later. But remember, as a DevOps engineer, our responsibility will be our main focus will be on two things. If there is no DevOps tool in our organization, we should know how to set up the DevOps tool and how to use it. And we should also be responsible for setting up the CI/CD process, continuous integration and continuous delivery. Consider we have a source code available in the GitHub. And as a DevOps engineer, what is our next responsibility? Our next responsibility will be like, consider we have a tool called Maven. Okay, let's take, we have a tool called Maven. What is Maven? Anyone knows what is Maven? Maven is a Java-based build tool. If you are not aware of all these tools, you can go through the Google and explore. Maven is a Java-based build tool. And I'm particularly mentioning that Maven is a Java-based build tool because it is only useful for Java-based projects, Java projects only. This build tool can be used only for Java source code. If the source code is written in Java, consider we have a source code in the GitHub, which is written in Java. Then only we can use Maven as a build tool. Then only we can use Maven as a build tool. Suppose if our source code is different, consider if our source code is Python. If our source code is Python, can you guess what might be our build tool? We have a build tool called PyBuild. We'll be using a build tool called PyBuild. If your source code is .NET, okay? If developer is writing a source code, if all the developers are writing the .NET source code and committing the GitHub repository, if the GitHub repository contains the .NET source code, what should be the build tool that we use? We will be using a build tool called MS Builder. So there are many build tools. If we are not aware, we will go to the Google and search like what is the build tool for Java-based projects, what is the build tool for .NET code, what is the build tool for Python. Usually, people they are not aware, right? So based on the technology, we use the build tool. If they're writing the code in Python, we use to search what is the build tool we use for Python. PyBuild is the build tool. So then now we need to understand what is a build tool. What is a build tool? You see here, developers are writing the source code. With the help of source code, if I take this source code, if I am going to take this source code directly, if I am going to put this source code inside in any server, if I keep the source code in any of the server, the application will not come into the live. We cannot see application up and running. Hope you are getting. So source code alone, we cannot make the source code alone to make the application come into live up and running. So if we want to make the application to run, we need to build the source code. Hope you understood. Okay, developers are writing the source code and they are committing the source code into the GitHub repository. Okay, once the source code is available, we cannot dump the source code into some server and we cannot make the application to run. That will not happen. The very next step as a DevOps engineer you need to know is you need to build the source code. For building the source code, we need a build tool. For Java related source code, we need a build tool called Maven. So the Maven is not only the tool that is available for Java source code. There will be many build tools for Java. There will be many build tools for Python. There will be many build tools for .NET. For example, you see, I'm not much aware of Python or .NET, but I'm aware of Java. For Java, there are many build tools. Like Maven is one build tool for Java. At the same time, Ant, A-N-T, Ant. Ant is also a build tool for Java. Gradle. Ant is a build tool for what is Ant? Ant is also a build tool for what? Which kind of source code we use? Ant. Ant is a build tool for what? For which kind of source code? Java only. Ant is a build tool for Java projects. And similarly, Gradle, Gradle, Gradle. Gradle is also a build tool for Java source code. We use Gradle, Ant, Maven. So based on the code they are writing, they will mention, okay, based on the build tool only, they will be writing the code. So we need to ask the developer, what is the build tool they are using? Okay. If the developer is using Maven as a build tool, we should be installing Maven in our machine. If the developer is using Ant as a build tool, Ant is a build tool, Ant as a build tool for building the source code, we should install Ant. So based on the developer, like based on the build tool that the developer is using, we will also use the same build tool. Okay, now you understood, hope you understood what is the build tool. So by using the build tool, what we will do is we will build the source code. What do you mean by building? Building is nothing but compiling and generating an artifact. So finally, what we will do is, what is build process? I will explain you. Once we build the source code, we are going to get an output. You see here, we have a source code available in the GitHub and we have a build tool called Maven. I'm going to use Maven as a build tool for building the Java source code. And I'm going to get the artifact. I'm going to get the file output file. I'm going to get one output file. And the name of the output file, usually we call it as an artifact. Try to understand what I'm doing. We have a source code available in the GitHub repository. GitHub is a repository, source code repository, where we'll maintain the source code. And once the source code is available, our next responsibility is like, we should know what is the build tool we must use for the project. So if Maven is the build tool, we will install the build tool called Maven, and we will be building the source code. Once we build the source code, what is the output that we will be getting? The output we will be getting is artifact. We are going to get the output in the form of an artifact. What is this artifact? So we will be getting some file like with an extension called consider our source code name is web app. So we will be getting the artifact in the form of webapp.jar, otherwise webapp.var, otherwise webapp.er. So even the artifact can be produced in even the artifact will be produced in 3 different ways. Either our artifact can be generated in the jar file, the dot extension called jar. Your artifact can also be generated with an extension called .var. Your artifact can also be generated with an extension called .ear. So actually within these 3 formats, we will be getting only one. So either we'll get a jar file, either we'll get a var file, or otherwise we'll be getting only a ER file, EAR. What is the full form of these files? You see, jar stands for Java archived. Webapp.var, var stands for web archived. Okay, jar stands for Java archived. Web stands for WAR stands for web archive. EAR stands for enterprise archive. So how actually we know how we can identify whether we are going to get a jar file or WAR file? So usually in the Java source code, developer will write the pom.xml. Developer will write the pom.xml. If we are using a Maven as a build tool, developer will write a pom.xml. In that pom.xml, he will mention whether he is going to, whether we are going to get the artifact in the form of jar, var, or er. Okay. So finally, leave about all these things. We will be getting some artifact. We'll be getting some artifact in the form of jar, var, or er. No need to worry about it. So once we get a jar, once we get an artifact, consider we are going to get an artifact in the form of jar file. What we are going to do with this, with the help of this jar file. So with the help of this jar file, with whatever the jar file that is generated, we are going to convert this jar into some Docker image. We are going to convert this jar file into Docker image. So to convert the jar into some Docker image, we need a Docker file. We need to learn Docker tool. I told you, right? Docker is a very, very important tool. We must understand. So once the artifact is generated, we should convert that artifact into Docker image. Why we need to convert that artifact into Docker image? You will understand. Okay, we are going to convert that jar file into artifact, jar or var file, whatever the artifact that is generated here. This artifact must be converted into Docker image. So for converting that, we need to use the Docker tool. Definitely, we need to use Docker. We should aware of Docker. So once the Docker image is available, we are going to push the Docker image into a tool called, we are going to deploy this Docker image into a tool called Kubernetes. We are going to push the image into a tool called Kubernetes. So as I told you, Kubernetes is a container orchestration tool. So once the Docker image is ready, we have the Docker image. We will be pushing this Docker image into the Kubernetes. And once we push that image into the Kubernetes, we can see the application up and running. Where you can see the application, your application up and running? Here in the Kubernetes. In the Kubernetes, we can access our application, or we can see whether our application is up and running or not. So this is the latest technology that we are using in application will up and run. Where our application will be up and running, we are, once the Docker image is available, once the Docker image is deployed into the Kubernetes, we can see that our application will up and run in the Kubernetes pods. So maybe if you are not aware of what is Kubernetes pod, what is Docker image, no need to worry about them. We will be understanding them in the future. Okay, but now try to understand. I'm trying to explain in a very simple way. Okay, so consider we have a source code available in the GitHub, and consider that too we have a Java source code available. Once the source code is available, we should have some build tool to build the source code. You might ask me, what is the necessity for building the source code? Without building the source code, we will not get an artifact. What is this artifact? This artifact consists of only the necessary files or the required files to run one application. It doesn't contain all the unnecessary files. Artifact contains only the executable files, or only the executable files that are required for running an application. Okay. Artifact doesn't contain the entire source code. Artifact contains only the executable files that are required to run one application. So that is why we call it as, that is the reason why we are going to build it by using a build tool, and an artifact will be generated as an output. Once the artifact is generated, we are converting, you see what we are doing? We are converting that artifact into Docker image. And once the Docker image, so to convert this artifact into Docker image, definitely we should have some knowledge. We should know about the Docker. We should know how to install Docker. We should know how to write Docker files. Then only we can able to convert the artifact into Docker image. Once we are done converting the artifact into Docker image, we will be pushing the Docker image into Kubernetes. So for Kubernetes, like, we should know how actually we need to set up Kubernetes and how we are going to push the Docker images, how we are going to deploy Docker images into the Kubernetes. All of them we need to understand. So, and then once the Docker image is deployed into the Kubernetes, we can see the application will be up and running. Any questions here? Any questions here in understanding the flow? This is the basic flow that you need to understand before we discuss about each and every tool. So if you don't understand this flow, so if I start with the particular, if I start with the tools and all, maybe you cannot connect all the tools. You cannot interconnect, or you cannot assume like how actually the flow happens. So now you see here in these tools, any questions here? I'm not able. My voice is not clear. Is it only for you, or I don't know? Are you able to hear me properly?
Yes.
Okay. Okay, then any questions from today's session? Like, hope you understood this in this flow and all. Here, I would like to add one thing. I would like to add one more tool here. And you see here, we have a Jenkins, right? We have Maven tool here, right? So here, today what we are doing is we are using Jenkins as an automation tool. So how all these things will happen? All these things, we are not going to do it manually. Okay. So we are using a tool called Jenkins. I told you what is Jenkins, what is the type, what type of a tool is Jenkins is. Jenkins is a CI/CD tool. I told you, right? Jenkins is a CI/CD tool. So what is CI/CD? Continuous integration and continuous delivery. Meaning, so this Jenkins will automate all the tasks. How Jenkins is going to automate all the tasks? So Jenkins will pull the source code from the GitHub. What we will be doing is, we are going to integrate this GitHub with Jenkins so that Jenkins will pull the source code. Jenkins will pull the source code from the GitHub. Jenkins will apply a tool called Maven, and it will build the source code automatically. We will set up a job once. We will configure the job once in Jenkins, and from the next time onwards, it will perform the task automatically. We are automating the tasks here. That's the reason why we were able to do the project. We were able to finish the project in a very short time. So Jenkins will automatically apply the Maven tool, and it will build the source code. Once it builds the source code, what is the output that we will be getting? Artifact will be generated. Once artifact is generated, Jenkins only. Okay, Jenkins will build the source code by using Maven. Artifact will be generated. Jenkins will convert this artifact. Okay, we are going to write some Docker file. So Jenkins will execute that Docker file, so that we are going to convert the artifact into, Jenkins will convert the artifact into Docker image. And finally, Jenkins will push the Docker image into the Kubernetes. Everything will be doing by the Jenkins only. Jenkins will automate by pulling the source code. First, it will pull the source code. It will build the source code by using a Maven tool. And once the artifact is generated, it converts the artifact into Docker image. So for all these things, we are giving the inputs. We are setting up, we are configuring the task. Jenkins doesn't know how to do, but Jenkins will do the routine task. So once we configure the task, once we configure the job, Jenkins will run the same job every day, whenever we want. So if you want to run the job every day, if you want to run the job for every 1 hour, if we want to run the job for every 2 days, or if you want to run the job whenever a developer commits the source code, whenever a developer commits the source code, if you want to run the job, even that time. So Jenkins is a CI/CD tool. In one word, I can say Jenkins is a tool which is used for automating all the tasks in DevOps. Jenkins is the only automation tool that we are using for automating all the tasks in DevOps. Any questions? Okay, any questions you have? And if you don't have any questions, and I would like to give a task, okay, people who doesn't have an AWS account, Okay, people who doesn't have an AWS account, I request you to go and create one AWS account. Why? Because this course is mainly AWS DevOps. So whatever the DevOps tools that we were discussing, suppose if I want to install Jenkins, so we will be installing Jenkins in the Linux environment. See, all the DevOps tools will be installed in Linux environment only. We are not going to do it in Windows environment. Why? Because most of the organizations, 99% in most of the organizations, we used to install all the DevOps tools in the Linux environment only. So that's the reason why we need a Linux server. Okay, we need a Linux server, and that too, we will be using that Linux server from the AWS cloud. We will be using that Linux server from the AWS cloud. Okay, so we will create one Linux server in the AWS cloud, and we will try to install all the DevOps tools. We will discuss each and every DevOps tool in detail from the next session onwards. And before that, we need to start with the Linux commands. Tomorrow, we'll see. Okay, before that, you can try to create accounts, AWS accounts. Once you have AWS account, most of you will have an AWS account. If someone is not having an account, you go ahead and create it. It's a very easy process. Go to the Google and search like how to create an AWS account. If not, I can explain you tomorrow how to create an account in the AWS cloud, and we'll create one server in the AWS cloud. We'll connect to the server and we will try to learn Linux commands. We are going to learn Linux commands in the next session. Once we are done with the Linux commands, we will be moving forward and we'll be discussing about the first tool called GitHub. Okay, we will start with GitHub. Then we will go for Jenkins, Maven, Jenkins, Docker, Kubernetes, Terraform, Ansible. This is how actually the flow will be. Any questions we have, we'll be discussing now for a few minutes. Otherwise, we'll wrap up this call. Thank you all. I'll be sharing. Someone is okay. Someone is okay. No problem. Please go through the video. I'll be sharing this in the group. Okay, I'll be sharing this recording in the group. So please go through the recording once again. If you have any questions, please let me know. Thank you all for joining the session. Let's meet tomorrow for the next one.